Hello everyone, today we'll be comparing RAG versus fine-tuning approaches. We'll be covering 5 key areas today. We'll first start with clarifying what RAG and fine-tuning approaches actually mean at a technical level. Second, we'll be examining a 4-factor decision framework where you can apply to specific to your business case and use case and requirements. Third, we'll look at specific scenarios where RAG is the right choice with actual examples. Fourth, we'll examine where fine-tuning makes more sense, and then again following up with the examples for that. And finally, we'll be discussing a hybrid approach where you might be using both together, which is more often the case in production systems. So let me first start explaining what these two techniques actually do, and then we can start diving in more deeper for each one of them. So first we'll start with RAG, which stands for Retrieval-Augmented Generation. In this approach, you retrieve external knowledge at the moment someone makes a query. The system searches a vector database to find relevant context. It then injects those relevant documents retrieved from the vector database directly into the prompt you send to the large language model. The model itself remains completely unchanged. Your knowledge updates instantly because you'll be adding new documents to your data. The cost structure includes per query retrieval operations combined with the large language model's inference costs. Since you're adding a retrieve context to your prompt, your context window gets larger, which affects the pricing as well. Now, fine-tuning works a bit differently. In this approach, you retrain the model's internal weights using domain-specific data. This encodes knowledge directly into model's neural network weight. At the inference time, you don't need any external retrieval, so the model already has the knowledge embedded in structure as part of the fine-tuning. The model's response patterns are permanently altered based on your training data that you use as part of the fine-tuning process. The cost structure is one-time training expense, which can be pretty substantial, followed by the standard inference cost without the retrieval overhead. The key difference between these two approaches is that RAG adds context dynamically at query time, while fine-tuning modifies the model itself before you can deploy it. RAG is like giving someone reference materials to consult, whereas fine-tuning is like training someone so they internalize the knowledge. This distinction is essential because it determines almost everything else about how you'll be using each approach. Understanding this will help you make better choices for your specific business case and requirements. Now let's look at a decision framework which you can use as part of your work. Let me walk through 4 factors you should consider when making this choice. These factors will help you determine which approach fits your situation better. So the first factor is the data volume requirements. For RAG, this approach works with essentially any data size. You could have just 5 documents, or you could have 10 million documents, or even more. The system scales based on your vector database capacity. For fine-tuning, you need a minimum around 500 to 1000 high-quality training examples. The more examples you have, the better it will be. Below that, for example, threshold, the fine-tuning typically doesn't work well because the model doesn't have enough signal to learn meaningful patterns. The question you should be asking yourself is that, do you actually have sufficient training data? If you're just starting out and you have limited examples, RAG might be the only viable option initially. The second factor is update frequency. With RAG, updates happen pretty instantly, so when you add a new document to your vector database, it becomes available for retrieval pretty immediately. There's no retraining step involved here. However, with fine-tuning, updates require retraining the entire model, which can take anywhere from several hours to multiple days depending on your data size and model size. The question you should be asking is that, how often does your knowledge actually change? If you're in a fast-moving domain like news, medical research, or legal documents where information changes daily or weekly, then RAG provides a major advantage. If your knowledge is relatively stable, like for example coding conventions for internal framework that changes maybe once a quarter or once a year, then fine-tuning's retraining cost is much more acceptable. The third factor here is cost structure, which gets pretty interesting here. RAG has ongoing costs for every query, so you pay for retrieval operations and you pay for the large context windows since you're including retrieved documents in part of your prompts. This might range from 3 cents to 10 cents per query depending on how much context you retrieve. Fine-tuning has significant upfront training costs, typically ranging from around $5,000 to $50,000 or more for training runs, depending on the model size and your data set. But then again, your inference costs are much lower because you're not doing retrieval and your prompts are much more short. The break-even point typically occurs somewhere around 10 million to 15 million queries, though this varies based on your specific costs. The question you should be asking is that, what is your expected query volume over the next year? If you're serving millions of queries, that upfront training investment might pay off. If you're serving thousands, the ongoing per query cost to RAG might be more economical. The fourth factor to consider is that the domain specificity and what you're actually trying to achieve. RAG works best for your factual retrieval tasks and accessing current information. It excels when you need to cite sources or when answers require looking up specific documents. Fine-tuning works best for changing style, tone, and domain-specific reasoning patterns. It excels when you need consistent behavior or when you want the model to internalize domain convention. The question you should be asking here is that, do you really need facts or do you need a change in how the model thinks and responds? If you're building a system to answer questions from your documentation, that's something RAG can help with. If you're building a system to generate code in your company's specific style, that's something fine-tuning should be considered. So these 4 factors gives you a framework for thinking through the decisions systematically. Now let me show you specific scenarios where RAG might be the right choice to consider. Now let me walk through 3 real-world scenarios where RAG is clearly the better approach to use than fine-tuning. So the first scenario is a customer support with, let's say, extensive documentation. Imagine you have around 550,000 help articles and your content team updates these articles weekly with new features, fixes, and policy changes. RAG is the right choice here because the updates happen pretty instantly. When your team publishes a news article or modifies an existing one, it's immediately available for retrieval. You don't need to retrain anything here. The system retrieves the exact article text and includes it in the response. In production systems like this, we typically see around 95% answer accuracy because the model has direct access to the source material, and you need zero retraining, which saves substantial engineering time and cost. The second scenario here is the legal document analysis. Imagine you need to query across 100,000 contracts looking up for specific clauses, obligations, or risk factors. RAG is the right choice here because you're doing pure factual retrieval. You're not trying to teach the model legal reasoning, you're trying to find specific text in specified documents. RAG provides accurate answers with direct citations to source documents, which is pretty essential for legal work. You can show exactly which contract, which section, and which clause supports your answer. This verifiability is something fine-tuning cannot provide because fine models don't cite their training data. The third scenario is an enterprise knowledge repository. Imagine your company wiki has, let's say, 10,000 pages covering policies, procedures, technical recommendation, and organization knowledge. This content gets constant updates as policies change, new procedures get added, and systems evolve. RAG is the right choice here because you need access to the most current version always. You don't want to be answering with outdated information from a model that was fine-tuned last month, but it might not have access to the most recent documents. RAG gives you real-time access to the latest policies and procedures as soon as they are published. The common thread across these 3 scenarios is that high-volume documents, frequent updates, and factual queries where you need to retrieve specific information. The cost profile for RAG in these cases typically ranges from around 3 cents to 10 cents per query, which includes both retrieval operations and the language model inference with the expanded context window. This ongoing cost is acceptable when updates are pretty frequent and retraining would be impractical. Now next, let's look at the scenarios where find is much better approach and might be considered better than RAG. Let's talk about in what scenarios we should be considering using fine-tuning. So the first scenario is a medical diagnostic assistant. In this case, you need clinical reasoning patterns, not document lookup. You're not trying to retrieve medical textbooks, you're trying to teach the model how to think through different diagnoses and how to weigh symptoms and how to follow clinical decision trees. Fine-tuning is the right choice here because you're encoding diagnostic thinking directly into the model's weights. The model learns to reason through cases the way a clinician would. In production systems like this, consistent clinical decision making that follows learned patterns rather than just matching documents. The model internalizes the medical reasoning, which is fundamentally different from retrieving medical facts, which might be as part of the RAG approach. The second scenario is the code generation for internal APIs and frameworks. Imagine you have proprietary tools, internal libraries, and company-specific coding conventions that are not in public documentation. You would want the model to generate code that follows the exact patterns. So fine-tuning is the right choice here because you're teaching the model your internal patterns and conventions. The model learns how your team structures code, how you name things, which design patterns your team prefers. In a systems like this, your team typically sees around 80% reduction in syntax errors and style inconsistencies compared to using a base model which is prompt engineering. The model generates code that looks like how your team actually would write it. The third scenario here is the content generation with very specific tone requirements. Imagine you need to marketing copy in your exact company voice, following strict terminology guidelines and maintaining consistent style across all outputs. Fine-tuning is the right choice here because you internalize the tone, terminology, and constraints into the model itself. You don't need to include the detailed style guides in every prompt, so the model naturally produces content that matches your desired voice. In systems like this, content teams get on-brand material without extensive prompt engineering or manual editing. The common thread here is that across these 3 scenarios is that you're modifying how the model thinks and responds, not what the facts it has access to. You need style consistency, domain-specific reasoning patterns, and internalized behaviors. The cost profile of fine-tuning typically involves somewhere from $5,000 to $10,000 for tuning process, depending on your model size and your dataset size. So it can be much lower as well. Following that, there will be roughly around 1 cent per query for inference cost, so you have to keep that in mind as well. These costs make sense when you're serving high query volumes and when the behavior encoding is relatively stable over time. Now let's discuss what you might want to combine both approaches as part of a hybrid approach in your production use cases. Sometimes the right answer is not choosing between RAG and fine-tuning approaches, it's actually using them both together but strategically. The hybrid approach works something like this. You fine-tune your model for domain reasoning and consistent behavior, and you use RAG for accessing current facts and documents. Here's a concrete example. Imagine a medical AI system. You fine-tune the model on clinical reasoning patterns so it knows how you think through diagnosis, but then you use RAG to retrieve the latest medical research, recent drug interactions, and updated treatment guidelines. The fine-tuning gives you consistent clinical thinking, whereas the RAG approach gives you the access to the information that's too recent to be in your training data or that changes too frequently to justify constant retraining. This hybrid approach makes sense when you need both domain expertise encoded in the model and current factual information from external sources. It does require budget for both the upfront fine-tuning cost and the ongoing RAG retrieval cost. Is typically chosen by teams with higher query volumes where the investment actually pays off. So let me give you a practical decision checklist you can actually use. You should be using RAG when your knowledge updates frequently, you need citations to source documents, your query volume is under around let's say 10 million queries annually, and your factual accuracy with current information is your primary. You should choose fine-tuning when you need style consistency across outputs, you need domain-specific reasoning patterns, your knowledge is relatively stable over time, and your query volume exceeds around 15 million queries annually where the upfront training cost gets amortized. You should choose the hybrid approach when you need both domain expertise and current facts, so your use case generally requires both the capabilities and your cost structure supports both the training investment and the ongoing retrieval costs. Your next step should be calculating your expected query volume over the next year and determining how often your knowledge actually changes. These two numbers will guide you toward the right choice. So if you're serving millions of queries and your knowledge is stable, fine-tuning likely will make more economic sense. If you're serving fewer queries or your knowledge updates constantly, then RAG is probably the better path. And if you're in a complex domain where you need both reasoning patterns and current facts, the hybrid approach might justify the additional complexity. So that covers the decision framework for choosing between RAG and fine-tuning. Ideally, you should be able to understand and make a decision what approach makes sense for your specific use case, the 4 factors to consider, and specific scenarios for each approach and when to combine them. Now you have a practical framework for make this choice in your own systems. If you have any questions, please let me know. Thank you.